Solving first-order transient circuits is a 5-step process, which I've shown right here for you. And just note that at all these time frames, like t is equal to 0 minus and t at infinity, you're going to have to redraw the capacitor or the inductor in their steady-state model. So for example, for a capacitor, it's drawn as an open circuit, and for an inductor, it's drawn as a short circuit right here. Alright, so here we go to an example. Go up a little bit. Alright, so they want the capacitor voltage as a function of time. And just real quick, there's some different ways to show how a switch moves in a circuit. Certain textbooks cannot decide on one convention, but here I'm just showing you that basically after t is equal to 0, the switch will open. Right? Alright, so the first step is going to be to look at the circuit for t is equal to 0 minus. So here we go. We redraw the capacitor as its steady-state model, so as an open circuit. Alright, now here there's going to be a current propagating through the left-hand side of the circuit like this. Its current's going to be just 6 over the total resistance, or just 9k plus 3k plus 4k. This will be 375 microamps. Alright, so then we can use KVL to solve for the voltage VC. I'll just color 1 second. By doing KVL over here in this part of the circuit. So you'll find that VC of 0 minus is going to be equal to just 6 minus 4k times I, or just 4.5 volts. Okay, so that was the first part. Secondly, we look at the circuit for the infinity time, or just greater than 5 time constants. So again, we are still in steady state, so we draw it as an open circuit, well, the capacitor as an open circuit. And the switch is open now. So now that the switch is open, earlier it was closed, but now it's open. Now, basically, because there's this open circuit in series with the voltage source, the voltage source cannot push any current at all in the circuit. So basically, we have no current flowing in the circuit at all. So therefore, this voltage over here has to be 0. It's equal to 0 volts. Because basically the capacitor is not being supplied any kind of voltage at all, so it has to be equal to 0 volts. Next is to find RT, or R thevenin, for the capacitor. So here we go. Well, this 4K is in series with this open circuit, so same kind of deal. This 4K will not matter at all. Alright, so RT will just be the 9K and 3K in series, or just 12 kilo ohms. Awesome. Next step is to find tau. So RT is 12K. C was 100 microfarads. 100 microfarads. So we get 1.2 seconds. Alright. Then we just plug and chug. Alright, so get this color back if I can. Yeah, alright, sweet. So VC of infinity was 0. 0 plus was 4.5 minus 0 e to the minus t over 1.2. Now, when you have the infinity condition, which, this term right here, if that's equal to 0, it's called the natural response. And if it's non-zero, it's called the forced response. And that's not really too important, though it's good to kind of know. Alright, so this would be your final answer right here. Be sure to leave a thumbs up on the video if this helped you out in any kind of way. I'll see you next time.